In everyday life, we constantly make choices, even with the drinks we like. One drink gaining popularity today is matcha. Some students enjoy its unique flavor, while others prefer sweeter beverages. Because each student may answer differently, matcha preference is influenced by randomness and is a good example of real-life probability. In our study, the random variable is matcha preference, where 0 equals to likes matcha, while 1 equals to does not like matcha. This variable is discrete because it only takes two possible values.
We surveyed 30 students and recorded how many students like or dislike matcha. And the results is 19 students like matcha and 11 students do not like matcha. This becomes our probability distribution. Since these are all possible outcomes, the total probability is 1.
The mean, which is the expected value. To compute the mean, we multiply each value by its probability. 0 times probability of liking matcha, 19 over 30. 1 times probability of not liking matcha, 11 over 30. Multiplying by 0 gives us 0. So the only value that remains is mean is equal to 11 divided by 30 is equal to 0.267. Since our coding was 0 is equal to likes and 1 is equal to does not like, a mean closer to 0 means more students like matcha.
Variance tells us how spread out the responses are. For yes or no data like this, you simply multiply the probability of liking to the probability of not liking. So, variance is equal to 0.6333 times 0.3667, which is equals to 0.2321. This means there is some variation in the group but not large amount. Interpretation of the distribution shape. Our data has only two categories, which is the like versus don't like. So it does not form a normal curve on its own. However, if we surveyed hundreds of students, the proportion of students who likes matcha could start to follow the behavior of a normal curve.
Now, let's see how the normal curve works using our matcha survey data and how we convert values into z-scores to interpret them. Step 1. Identify the data. The total students surveyed is 30. The students who like matcha is 19. Their proportion, 19 divided by 30 equals to 0.6333 or 63.33%. The students who do not like matcha is 11. The proportion, 11 divided by 30 equals to 0.3667 or 36.67%. This proportion of 0.6333 will act as the mean for our normal curve. Step number 2. Calculate the standard error for yes or no data. We use standard error or SE to measure how much the proportion can vary. Step 3. Convert selected values into z-scores. We now convert specific sample proportions into z-scores to see how far they are from the mean. For example, suppose a future survey finds 80% of students like matcha.
Z equals to 0.0880.80 minus 0.6333 is about 1.91.
Step 4. Find the area under the normal curve using the z-score. We can find the area under the curve or probability. Z equals to 1.91, area to the left, is about 0.9728. Interpretation: about 97.28% of samples would have a proportion of students liking matcha below 80%. Only about 2.72% of samples would have a proportion above 80%, making it relatively rare.
Step 5. Find a proportion for a top percentage. Suppose we want to top 10% of samples for students liking matcha. Z is equal to 1.28 for the top 10%. Convert back to a proportion.
Proportion equals mean plus Z times SE. Proportion equals 0.6333 plus 1.28 times 0.088 equals to 0.744. The interpretation, a proportion of 74.4% or higher is in the top 10% of students liking matcha. Step 6. The summary. We converted values into z-scores to see how far they are from the mean. We use z-scores to find probabilities, the area under the curve. We also found raw proportions corresponding to a top percentage. Mean proportion liking matcha is 0.6333. The standard error is 0.088. This shows how z-scores and the normal curve helps us predict and interpret real-life data.
Our simple matcha survey shows how probability helps us understand real-life choices. By identifying our random variable, creating a probability distribution, and computing the mean and variance, we saw that most students prefer matcha. Using z-scores and the normal curve, we also learned how these mathematical tools help make predictions and interpret data in larger populations. This activity shows that statistics is more than numbers. It helps us make sense of patterns, preference, and everyday decisions.